The topic of this video is solving logarithmic and exponential equations. Let's look at a problem. Log base a of the difference x minus 8 minus log base a of the sum x plus 5 equals log base a of the difference x minus 4 minus log base a of the sum x plus 6. Solve for x. Use tips 1, 2, and 3. Okay, so let's briefly recap these tips. Tip 1 lists 4 different equations and some arrows for you to slide along. In this particular instance, our job is to take what we have been given and try to make it look like this. Log base a of m equals log base a of n. And then when we slide along the arrow, we're getting rid of the logs and their bases and just setting the exponents to be, the arguments to be equal to each other. So if we can make it look like this, log equals log, then the arguments must be equal to each other. Tip 2, since this is a logarithmic equation, it has both equals and log in it. The first step is to identify the domain. The last step is to throw away any solutions that are outside of the domain. And tip 3 says when you have two logs being added or subtracted with the same base and no numbers in front of the log, use Rule 6 or Rule 7 to combine them. And since we're subtracting, we're going to use Rule 7 once on the left and Rule 7 once on the right. Okay, so now that we've got a plan for how to tackle this problem, let's implement our plan. First, domain. So you can only take the log of a positive real number. So that means that this has to be positive and real, this has to be positive and real, this has to be positive and real, this has to be positive and real. Positive means bigger than 0, so I get x minus 8 has to be greater than 0, and x plus 5 has to be greater than 0, and x minus 4 has to be greater than 0, and x plus 6 has to be greater than 0. All 4 of these inequalities must be true at the same time. Let's solve each one for x. Plus 8, x has to be greater than 8. Minus 5, x has to be greater than negative 5. Plus 4, x is greater than 4. Minus 6, x is greater than negative 6. So what that tells me is x has to be greater than 8 and greater than negative 5 and greater than 4 and greater than negative 6 at the same time. This is called a compound inequality. And there are 2 ways to solve this particular compound inequality. Because all of the symbols are facing the same direction, we can use a very logical approach to solve all 4 of them at the same time. For example, if this says you can only use values of x that are greater than 8, and if this says you can only use values of x that are greater than negative 5, then we only need this statement for both of these statements to be true. Because if something is bigger than 8, like 9 or 10 or 11, then certainly it will also be bigger than negative 5. In fact, this one statement being true, x greater than 8, ensures that all of the other statements will also be true, and therefore this is the only one we need. Our domain is x is greater than 8. Now I mentioned that this is a problem from intermediate algebra. How did we solve that problem then? Well, we used a graphing technique. We graphed each one of the inequalities on a number line. So for example, if I put negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. If I put these values on a number line and I graph each inequality in its own color, then all I have to do is find the overlap of the shaded regions. For example, let's say I do the very first one, x is greater than negative 6. By first, I mean I'm working from left to right. If I were to graph this, I would have a parenthesis at negative 6, and I would shade everything to the right of it. I'm absolutely ruining my orange marker right now. All right, next one we'll do this negative 5. I'll do that in green. If x is greater than negative 5, then the graph would look like this. A parenthesis at negative 5 and greater than is to the right. So that would be every number that's to the right of negative 5. And if I do the next one, 4, I'll do that one in blue. That would be a parenthesis at 4 and shading to the right. And then finally, the last one, 8, I'll do that one in red. If x is greater than 8, that would be a parenthesis at 8 and shading to the right. Now looking at the shading on the number line, where do you see all 4 colors? Well, that would be over here. All the numbers that are bigger than 8. That is the reason why our domain is x is greater than 8. So there are 2 ways to get the domain. There's a logical approach and a symbolic or a graphing approach. Both are fine with me. I would say use whichever one makes the most sense to you. But if both of them make sense to you, use the logical approach because it's simply faster. Okay, so now that we have our domain, we're ready to now try to manipulate our equation so that we can get the variable x alone. We're going to begin by using Rule 7 once on the left and Rule 7 once on the right. When 2 logs with the same base and no number in front of them are being subtracted, Rule 7 says you can combine them into just 1 log by dividing your 2 log arguments. So on the left, we would have log base a of the fraction x minus 8 over x plus 5. Same idea on the right, we'll have log base a of the fraction x minus 4 over x plus 6. Now, by the law of logarithms, we can set these 2 arguments equal. Remember, the law of logarithms says if log base a of m equals log base a of n, then m equals n. Well, that's exactly what we have. Log base a of m equals log base a of n. If that's true, then m and n, the 2 arguments, must be equal to each other, and we don't need the logs anymore. So, now we get the statement x minus 8 over x plus 5 equals x minus 4 over x plus 6. And we've turned our college algebra problem into an intermediate algebra problem, specifically a proportion. Proportions can be solved by setting the cross multiples equal to each other. If you multiply the x plus 5 by the x minus 4, that must be equal to what you would get if you multiplied the x minus 8 times the x plus 6. So writing this down, we would have x minus 8 times x plus 6 equals x plus 5 times the x subtract 4. We can solve this quadratic equation using FOIL. So we'll FOIL on the left and we'll FOIL on the right. First, we'll begin by FOILing on the left. We get x squared plus 6x minus 8x minus 48. Now FOIL on the right. X squared minus 4x plus 5x minus 20. Next, combine your like terms. X squared minus 2x minus 48 equals x squared plus 1x minus 20. Next, notice that we have an x squared on the left and an x squared on the right. So if we subtract x squared on both sides, those will both cancel. This is good. This saves us time and energy. So now we have negative 2x minus 48 equals x minus 20. The next step is to try to get all terms with x on one side and all terms with no x on the other. So this gives us, when a term changes sides, it changes signs. So this gives us positive 20 minus 48 equals x plus 2x. Combining like terms on both sides, on the left we get the number negative 28, and on the right we get 3x. Dividing both sides by 3, we get x equals negative 28 thirds. And as long as that's in the domain, that will be our final answer. So let's compare it to the domain. The beginning of this problem, when we determined the domain, we found that x has to be greater than 8. So is negative 28 thirds greater than 8? The answer is no. This is negative. If something is bigger than 8, it's going to be positive, like 8.5 or 9 or 100. Negative is not bigger than 8. So this means that our only proposed solution is extraneous, which leaves us no solution. Now, it can be frustrating to do this much algebra only to find that the answer is no solution. So let me share two things with you. First of all, it can be good news that there's no solution, which means there's no answer to check. It reduces the amount of work you have to do. Second, it's extremely useful to be able to prove that there's no solution to a problem. Someday in the future, you may have a boss that you report to who gives you a task and gives you certain criteria that you have to beat. It's possible that that will be impossible to achieve. So, if you can state, using a series of criteria, that you can prove that there is absolutely no solution, this is useful information for you to take back to your boss, your supervisor, and say, for the conditions that you've required me to meet, there is no possible solution. So which one of these conditions would we like to alter so that we can find an acceptable solution to this real-world problem?